Very good. E. coli, K12, is a BSL1. Bacterial safety level 1. E. coli K12 is the one that we use a lot. If you don't have any particular reason to choose another type of bacteria, use that. If you're trying to mimic some specific bacteria, then use that specific bacteria. But if you're just trying to figure out general bacteria, then this is your general bacteria. E. coli we have in our stomach, we have in our colon. It's not that bad, right? And we have it naturally. So this is the best one to use. It is safe. And when I say safe, I mean not that it's safe to lick, but it's safe to work with. Okay? People lost? Okay. Does anybody else know the bacteria they're working with? Anybody have one that they know they're not working with this one? Streptococcus is another one, right? Staph. You don't really work with staph too much. Here's the deal. BSL level 1, we are allowed to do in the high school. Right? You can do it in an area like this. It's relatively, if we control it, right? You can't do this at home. They won't send bacteria to your house. That's in here. BSL level 2 would be, no, you can't do it at a high school. You can do it at a university or NIH. Right? We're talking about higher danger bacteria or viral agents. Things that if they were to get spread around, you would be very sick quickly. Right? There are even things on the BSL level 3 level. Okay, where might you find BSL level 3? Serious research facilities like the Centers for Disease Control in Atlanta. Right? Anybody know an example of an agent they'll have in there that they don't really have anywhere else? Like samples of the plague. You guys know what the plague is? The bubonic plague? That if it got out, it would wipe out 1 million people. They don't really want that out, right? So they kind of keep that in a tight room. Like anthrax. You guys ever heard of anthrax in the news before? Highly, toxic. People have been accused of using it to kill people before. At any rate, those are very dangerous things. We don't play with those things. Nobody does. BSL level 2 you could possibly do. But realistically, BSL level 1 is what we always deal with. So you've got to find out what that is. Now, how can you find out? It says you can look at the biosafety level 1, and it must be BSL level 1. If it's not, you cannot work with it at school. You will purchase these things, by the way, at those particular sites. So I'm on the second little circle on the BSL level 1. All right, we used to have an example that was filled out. We'll have to see it.
Let's see, students.
We'll fill it out.
I think the first one and the third one.
I don't know.
Do you need to try again?
Okay, so everybody flip your sheet over. You guys see this up there? I went and looked this up for you today. I updated the pricing. These are the things that you will need to order. Now, you don't order everything. You pick out what you need. It says Ward's Science and then Carolina Natural Science. So they're just two different companies that have the same stuff. So you can pick it up. Okay? So when I refer to you needing to buy your own bacteria, I'm referring to these two companies. What happened? Go ahead. Okay, so it says purchasing supplies. I'm back on the front again. What will we give to you for this project? So what's one thing we're going to have to do? The incubator. Very good. An incubator is a place, a nice warm place that you can snuggle up in and grow. Right? And by you, I mean bacteria. Okay? You wouldn't want to go in there. It's kind of gross. But you're going to take your petri dishes and overnight you're going to leave them in the incubator. It is warm. The bacteria will grow much faster there. Right? If it was cold, they don't grow as fast. And so what we do is we put them in an incubator. Okay? So we will provide that for you. What else do I give you?
Biohazard.
Okay? Biohazard bags. Biohazard bags are things that actually you're most likely going to order them because they come with the kit. If you buy the student bacterial kit, it comes with 2 bottles of agar, 20 petri dishes, 20 swabs, all that. It comes with a biohazard bag. This is the most common thing that people buy. They typically buy maybe 1 or 2 of them, depending on how many you need. That'll be fine. You can order those. biohazard bags. We'll have them for you if you don't afford it. And then bleach. Bleach is obviously going to be used to sterilize. Be careful with the clothes that you wear, because they will get bleach on them if you clean that table and you got bleach. It gets over your pants. You're not getting that bleach out. All right, that's permanently damaged the ink in the pants. Okay, what will you need to purchase on your own? I have bolded it for you. You are buying your own agar. You guys know what agar is?
Jello.
It's kind of like Jello, right? It really is. It's food for bacteria.
It's seaweed.
Here's a picture of some agar, an actual slide. Right, so this is an actual plate. The agar is the stuff here. It's this is kind of green. You can see a film of bacteria grown on it. You really can't see it that well, but nonetheless, agar is it's just a food. You got to feed the bacteria, right? So we feed it agar. Now you can't really see the bacteria, it's so small, but we basically heat it up. It comes as a solid. It's like Jello. You put it in a microwave in a nice bottle. You melt it. You take your little petri dish and you keep it closed until you need to. You open the petri dish. You pour in a little bit of agar. You close the petri dish. And we'll talk about why you open and close it wrong a little bit. But the agar just hardens in a couple minutes, and then you're going to spread some bacteria. Okay, so agar is that stuff there. You're also going to order, obviously, your bacteria. You're going to order your petri dishes and your swabs. Swabs are basically going to be sterilized. That's the key word for today, is sterilized. You're going to use those to spread your bacteria. Okay? Cool. So all the stuff you need to order. Oh, what's that?
What do you
Oh,
use
that.
So when do they order the students? When do they place the order and
That's
how
a
should they,
good
who
question.
should they send these supplies to?
Good question. So here we go. Let's write this down. To the left of completing your project, here's what I would write down if I were you. When you're ordering this stuff, all shipments are sent to Fairfax High School. So you need to write on there, send all packages to Fairfax High School. Now, I don't think that the FBI is monitoring what Carolina Scientific receives or sends out, but you don't want them to be coming and knocking at your door if you order something that you shouldn't have ordered and it arrives at your door. Okay? Now, that's probably not going to happen. But if you order something that's a little sketchy and somehow it gets through, because they're not supposed to send this stuff to your house, it's supposed to come to school only, you don't want to deal with that. So everything comes to the school. They shouldn't even
Put
let
your
you do it.
teacher's name on it,
Correct. That's the second most important thing.
all right?
is
Put your teacher's
put
name.
your teacher's name on it.
If it just comes to the school and they don't know to which teacher it should go, then the box has disappeared and you've lost your money.
And
You cannot
sorry.
start your project on time. Does that make sense? You
Because
would say, I ordered it, but we haven't received it.
and they don't know. I mean, the people who receive the packages are not us, right? And so they're gonna get a box that says Jeff Serio on it, right? Which is his dad. They're gonna have no clue who Jeff Serio is, and neither will the 10 people who happen to look at the box. If it says Mr. Owens underneath Michael Serio, right? I'll be able to figure that out. But if you don't put our names on it, your packages get lost, and that happens a lot. Good. So those are the two most important things about ordering. Send it to the school and specifically to the teacher.
I don't know if you went over this, Mr. Owens, but how early should they order their supplies?
Good question. So we're about to get to that part when we get to the dates. So, starting. Completing your project. Starting November 1st, you can sign up for a time to work on your experiment. So that's coming up soon. All right, 12 days. Between November 1st and November 30th, you need to sign up for a time. Each teacher will basically have their own sign up. Okay? You're going to be doing your project most likely in either this classroom or in my classroom across the hall. That's where we're going to keep the incubator, one of these two. I don't know where that is. The petri dishes will stay in the incubator. But you're going to sign up with your teacher to know when your project's going to happen. Your teacher will then communicate with us, so we have one centralized space where we know all the projects. Okay, all experimentation will take place on December 3rd through January 18th. Now, obviously, it won't take that long. You've got choices. Okay, let's skip the last point on that little paragraph area. It says plating days. You guys see the 4 plating days? plating day?
December 3rd.
December 3rd, right? That is a Monday. All plating days are Mondays. Why is that? Because you start on a Monday, you go Monday, Tuesday, Wednesday, Thursday. Did we go Friday last year? I think we did 4 days. Yeah. It's either 4 or 5. The jury's out on that. Traditionally, at the 4th day, you've already kind of seen all the results you're going to see, and saying 5th day is not going to matter. Okay? So let's just go ahead and say 5 days for now, and then we'll tell you what otherwise. You must start on a Monday so that you don't run out of time, and then you have to show up on a Saturday. And if you're my student, I'm not coming in on Saturday. You can convince Miss E to come in.
No, I'm not coming.
Neither is she. We don't want to come in. You don't want to come in on Saturday. Go do something else. Please don't do this science project. So you guys start on Monday. Okay. It says you should sign up to start your experiment on a Monday, and then you will come in every day for 5 days. This officially says 5 days. I believe last year we only did 4 days. Following this, start your project to monitor your bacteria. Okay. Now let's be clear about this. Several of you are working with partners. Let's say there's 3 of you. On the first day, where you do all of the work getting it set up, all 3 of you have to be there. Okay? Because what's going to happen? You're going to plate all of your agar, which means you're going to microwave it, you're going to pour it into the petri dishes, excuse me, you're going to let it harden, you're going to put your bacteria on each agar plate, and then you're going to do something else to it. And that just depends on what you're doing. That takes time. It takes probably about 2 hours to do the whole thing. Maybe less if you're efficient. But everybody must be there that first day. Days 2, 3, 4, and maybe 5, you really only need 1 person there to collect the data. So what data are you collecting? I don't know what you're doing, but most people are measuring what we call a zone of inhibition, and I'll talk about that in a minute. Okay. So day 1, all 3 of you need to be there if you're in a group. Days 2, 3, 4, and 5, only 1 person from each group is to be there to collect their data. Okay. Make sure you guys exchange your data books so you know what to do. All right. Once your experiment is complete, you must dispose of your petri dishes. The worst thing you can do is to finish your project on a Friday, leave them in the incubator, and then just stay there for like a week, 2 weeks, 3 weeks, because you know what? Your name's on it. And all I'm doing is I'm opening the incubator and I see your name on there and I'm like, they're getting 0. I'm going to give them a 0 on every assignment that comes up until their project is removed out of there. And I'm not going in there and getting it. It's your project, not mine. Okay? Get your stuff out of there. We don't want to clean up after you, especially this stuff. Yes, ma'am.
Say, Mr. Owens, I decide to talk to my group members and I decide to start my experiment on December 3rd. Okay? That's the first week that students are allowed to do the microbiology project. Why would I like to do an earlier date? In case something happens to my project, I still have the backup dates in which I can ask, is there an open space? Can I repeat my project? Because this went wrong. Okay? So say I sign up for December 3rd. I have to have my supplies ready before I start my project. How long does it take for the supplies to arrive? Let's give it
2 weeks.
2 to 3 weeks.
You should order it 2 weeks before, at
Okay.
minimum 2 weeks.
So I don't want to be, we are doing, if you are doing it December 17th or January 7th, do you want your shipment to arrive during winter break here? No. Nobody's going to be here in the building. Okay? So please, make sure that you order your supplies 2 to 3 weeks before your start date of the project so that you have the materials available for you to do your project.
We are not involved in that at all.
Yeah. It's,
You guys do it on your own. You make the call on your own. You pay for it on your own.
you
send
don't
it
have
to
credit
school.
cards, you see. It's only your parents, right?
We don't do that. So that's all on you.
Okay?
Okay.
So decide a date quickly and order your supplies quickly, all right?
Right.
I would say within 3 to 4 weeks. If the shipment arrives early,
Oh,
then
well.
we'll keep it in the refrigerator for you. Okay? You don't want to do it too late.
Let's talk a little bit about sterilized tanks. So first of all, I want you to see that this is a PowerPoint microculture initiation. This is posted on my Blackboard site. It will be posted on all the science teachers' Blackboard sites. There's 3 documents that are posted all about microbiology. Okay, so make sure you guys go look at those, review them at some other time, take this stuff in, make sure you want to do this, and just kind of peruse the sites. There's a lot of stuff out there that can teach you how to do this stuff. Okay, this is kind of what we're looking for. Some of you are measuring what we call a zone of inhibition. You guys see the zone of inhibition? A little ring right there. I'm going to show you about that in a second. All right. There's also one that says testing bacterial cultures. This document is on Blackboard. And then finally, there's one more I will post up there. Here's what you're going to do. You're going to get your Petri dish.
Mine too does the same thing.
Use whiteboard now too. You're going to get your Petri dish, and you're going to spread your bacteria.
I want to touch that pen, Mr. Owens.
So you got a Petri dish. It's plastic. It has 2 sides. Okay.
Good, very good. Good smart, Mr. Owens.
I want you to see this.
Sally, did you hear that Jenny got mad because she made a mole?
Okay. So this bag is no good. Why? Why would this bag be no good to use for your project? It's open, right? So contaminants from the air have, permeated this bag. They've possibly gotten into the plates and they contaminated it. Of course, this one has a little thing.
I think this last year my student got it.
Yeah, weird. This is not a traditional one. Normally, there's no like little divisions. Most of them are just flat. They're going to come in a nice sealed container, and that's good because the company that made them and manufactured them sterilized them, right? Which basically means they killed any microorganisms around these, in these, on these, sealed them up in a nice, happy environment, and there's nothing growing in there. And that's what we want. Because the main thing about this and doing research with microbiology, and some of you may go on to college and graduate school and whatnot, and you may end up doing stuff like this. The number one thing is control. Controlling all the variables. Because we only want one thing that's different from all the Petri dishes. And that's whatever you're testing. Let's say you're testing hand sanitizers. Okay. So let's talk about hand sanitizers. Right? Here's my Petri dish. I have it. It's like this, right? So what I don't want to do is I don't want to take it like this and start walking around. Because now what's happening?
It's contaminated.
I'm contaminating it, right? Now, is like there Ebola plague in the air here? Probably not, but you just don't want to. You don't want to introduce anything in here that doesn't need to be in here. So we keep the lids closed as long as possible. You get a bottle of agar. It literally looks like yellow goo or green goo. Okay, it's hard. You microwave it, it turns into liquid. It's hot. You take this. You take your little bottle of agar with a glove. You take off the lid like this. You pour it in, just enough to fill the bottom, and you cover it back up. Now, notice how the big side is on the top. Okay, the problem is if I do it like this, and I pour the agar on the bottom, what's this thing going to do? It's going to stick into it, right? It's going to be a mess. So logic would see that you would want to put the small side on the bottom and the big on the top. Okay? And we'll help you with that on the day of. Most of you would figure that out on your own. Not everybody, because I've seen it. But nonetheless, this is the way you want to do it. Pour in the agar, close it. Right? It's going to take a little time for it to harden, but now we've got a nice, relatively sterile technique going Agar's going to harden. Let's assume the agar is hard. Now what do we need to put on the agar?
The
Your bacteria. Very good. So what we do is you get what we call a slant, or a tube of bacteria. It's literally like a tube. It looks about like this, but it's glass, right? It's about this size. And
A test tube.
It's basically a test tube with a screw top. And it's got agar poured in there, and it's got bacteria on the surface. And you take a swab. It looks like something to clean your ears, right?
You want to remember this when you order your supplies. You order a slant. Okay?
It's a slant. Slants. It's on the back, I believe. It's not. Let's check.
And do not order all the different types of microorganisms. Only one that is relevant.
Again, you don't want to get any lists. No federal lists when you order random stuff. Okay? So we've got bacteria, we've got our slants, our little test tube. You unscrew the top, we put the top down. You take your little Q-tip, which is basically a fancy Q-tip, you stick it in there, you rub it on the surface, and that's all you need to do. You take this. It's sitting on the table, of course. I got the lid off. It's on the table. Take my bacteria. Just wipe on the surface. Just gently wipe on the surface. You're not going to see anything happen, right? It's so small. But the bacteria is going to start growing quickly, right? So I've wiped on the surface. I have bacteria on a Q-tip. What am I going to do with this Q-tip? I'm not going to clean my ear, right? That'd be bad. So you're going to put it back into the package, seal it, and then we're going to put it in one of those biohazard bags. If it's E. coli, we may throw it in the trash can. Maybe we should. Okay. So now I've got bacteria on the agar. I close the lid again. Keeping it closed is what we want to do as long as possible. Sterile technique. Now, I've done that to my 5 levels of my IV, if I have 5. Let's say I have 4 hand sanitizers in control. How many Petri dishes do you use for each level?
2,
No,
3,
no,
4,
5.
It's on there, 5. I believe it's on the sheet. Yes, you see in the middle, the 2/3 down the paper, it says keep in mind, you will do 5 trials per IV. So if you're testing 4 hand sanitizers, that's 4 times 5 is 20. Plus, you have the control. So that's 1 more times 5. So that's 25 total Petri dishes. You've got to figure out how many Petri dishes you need. We're not going to do that math for you. Okay? So that's our Petri dish count. I pour all of them. It takes time. That's why you need your whole group there. We are not going to hold your hands and pour all the agar for you. There's going to be a lot of you there. So, all the agar is poured. All the bacteria is wiped on. Now what do? Well, if you're doing hand sanitizer, how do you test which hand sanitizer is best? How do we get the hand sanitizer on the bacteria and agar? Who knows?
the chromatography paper?
Okay, chromatography paper. Yeah, okay, there's a specialized name for it, what we're going to make that. Anybody know what the specialized name of it is? What? A disc. It's called a sterile disc. A sterile disc is literally a piece of paper or chromatography paper that we use a hole punch. It just hole punch a little bitty, little tip. We want the piece that you normally throw away, the hole punch. That's what
When
we
you go
want.
punch a paper, you get little circular things.
The little circle thing.
The disc looks like that.
That's it. We literally use a hole punch. Well, here's the thing. We hole punch it with just a normal hole punch. But what do we have to do to those discs first? We have to sterilize them. So how do we do that? Well, there's an easy way. You put them in the microwave for about a minute. Put them in a napkin, put them in the microwave, heat them up. So we kill anything on them. Now, we have a sterilized disc. We've got hand sanitizers that we have strategically put into beakers that we cleaned beforehand. Okay? Sanitizer 1, 2, 3, 4, and then the control. How do we get the hand sanitizer with the disc onto this?
So there's the liquid soap, which is the hand sanitizer. There's this little paper that's a disc. And there's your petri dish, which contains agar.
What do you need?
What do you need? How does the process work?
Something to grab it. You need your fingers?
Sterile application stick? Applicator stick?
Forceps or tweezers.
There we go.
Okay, all right, but wait. If we use tweezers, can we just use normal tweezers? We have to sterilize them. How do we sterilize things like that?
Alcohol.
They're faster
Good.
than us.
Good guess, but you don't put metal in microwaves. It's not a good idea. You can use alcohol, rubbing alcohol, and or
Bleach.
And
you wouldn't use bleach because
who's
you would
watched the
kill it.
YouTube video on this? Sterile techniques. Nobody watched it?
Hints. Fire. We're going to use Bunsen burners. So you guys are going to have a Bunsen burner going. You're going to leave it on for a little while, and you're going to put the tip of the little forceps into the flame. I wouldn't hold it there long because that thing's going to get real hot. You're going to let it cool off for a little bit. You're going to grab the little sterilized disc, and you're going to dip it in sanitizer 1. I got it in my hand, right, or on my tweezers. I take the lid off. I put it right smack in the middle. I just lightly tamp it down. I put the lid back on. Now, your magic's happening. Right?
So the soap will slowly leach out from the disc into agar. And if it is, as you say, one of them that contains a disinfectant that's going to kill the bacteria cannot grow in that zone. Does that make sense? The more efficient it is, the longer will be the length of the zone of inhibition. Does that make sense?
So, day 0, no ring. This is what should happen. Day 1, you should start to see a ring because the stuff's
It will
going to leach
clear
out.
out. The bacteria will not be there.
You're not going to see any bacteria in that ring. You're going to see it out here. Day 2, you should see bigger and bigger and bigger, and theoretically it should get bigger. It will start to taper off after about day 3 or 4. Okay, that's why we don't continue on for 15 days because it just won't work anymore. Okay, so I showed you at the beginning a beautiful picture of it. This is someone who did 4 on 1 plate. We traditionally only do 1 disc per plate. Traditionally. The rings are really small here. You guys see, this is the bacteria growing after probably at least a day. You can see the kind of like greenish color. That ring is your zone of inhibition. The bigger the zone of inhibition, you think the better the hand sanitizer or the worse the hand sanitizer? Better. Okay? The better, because it's killing more bacteria for the same amount of hand sanitizer.
There's a big difference to the second slide. The second slide really is.
Oh, yeah, here we go.
That one, the bottom,
And this one,
Yeah.
it's a huge ring.
and the one above it has a really small ring.
Yeah, you guys see this little zone versus this huge zone. So how do you measure the zone of inhibition? You literally just measure the diameter. And that's your data that you'll report, that you'll graph, and that you'll analyze. Over 4 days, the zone of inhibition grew this much. You'll average them over all the trials. Okay, that is basically how this works. Yeah. Okay, good question. What if you're growing bacteria? So you're maybe swabbing like the water fountains or a keyboard or whatever, heaven forbid. Is that something like what you're doing? Makeup foundation, like bacteria in that?
Is that nothing that's going to kill the bacteria? It's the same
So it's the
process.
same.
You dip the disc.
So you might want to make a solution of that, of the makeup, but you don't normally have liquid makeup. You don't have I'm not an expert.
Neither am I.
I know what you're talking about. It's likely that you're going to make a solution when you're going to put it in water because there's a lot easier to dip it in. We'll give those details. It's probably the exact same difference. More effective. The more effective it is at being anti. Yes.
If you're in a group, do you need 1 D6 form?
You should have only 1 set of forms per group from now on. The only thing you need multiple of is the Form 1B. That's the one all of your parents have to sign. It says if you hurt yourself, it's your own fault, not ours. Okay? Okay.
Bottle of coffee.
The main thing is sterile technique. Here's the deal. This is not going to be perfect. It's not going to be perfect. You're not going to get amazing results every time. It just isn't going to work that way. But we want you guys to get really good practice because all of you are going to go off to college and all of you are going to have an opportunity to go to a lab and do this stuff. Every one of you, if you go to college and they have a biology department, if you walk in and say, I'd like to walk in and work in a lab, every one of you will be allowed to, unless you got an F your first class. Hopefully you won't. So this is something you really can use when you leave it. You really can. Any more questions for us? Yeah. If you have questions for us, you're welcome to stay. Otherwise, we're